In today's video, I want to talk about categorization of automation in software development, which is a parallel to the level of automation used in self-driving vehicles. So the level 0 is manual coding, which means there's no automation, everything is written from scratch by a developer. And level 1 is basic code suggestion, which is tools like Copilot suggest some small code snippets to assist. And level 2 is automated refactoring or debugging, which is more complex automation, but is still supervised by the human developer. And level 3 is conditional automation for some specific tasks like unit test generation or code translation with some tools like DiffBlue or Transcoder. And then the level 4 is almost complete automation of software tasks, tools that can take on entire development processes. And the level 5 is full automation, which is hypothetical future. Well, the system is autonomously creates the entire application from the highest level goals, with there's no human intervention is needed. So this breakdown mirrors the progression of self-driving automation, with each level representing a step closer to the fully autonomous development. So let's try to walk through each level with some concrete examples, and I will connecting them to the real-world tools and the practicals to make this clear. The first level is level 0, which is no automation manual coding. So at this level, the software development process is entirely manual, just like driving without any assistance. So the developer writes code from scratch without any automated tools to assist in it with typing, suggestion, or error checking. One example is a programmer. He's using a basic text editor like Notepad or Vim to write in Python or JavaScript code purely from their knowledge without any support from the environment. So they just manually type out the syntax functions and perform the error checking or debugging on their own. The level 1 is code completion, which is Copilot cursor code completion. So this is akin to basic driver assistant technologies like adaptive cruise control in cars. This developer is still fully in control, but gets some helpful hints or automated suggestion. So this enhances the productivity by providing some auto-completion, real-time suggestion, and small snippets of code. For example, GitHub Copilot or Cursor, they offer code suggestion as developer types. For instance, while we're writing some function, Copilot may suggest the next logical line of the code or autocomplete a function signature. So it helps to fill in repetitive patterns, but doesn't do any higher level thinking. The level 2 is partial automation, which is Copilot chapter refactoring. At this level, there is more automation, which is comparable to some features like Tesla's autopilot, which allows the car to manage certain driving tasks, but it still requires the driver to be engaged. So similarly, the developers can use these tools to refactor larger chunks of code, to perform more complex operations, or even debug, but the developer, the human, must still oversee and guide the whole process. The example is using Copilot Chat or Cursor to automatically reflect a block of code or just convert code from one format to another. So a developer could ask the Copilot Chat to clean up a piece of code, optimize it for performance, or suggest alternative implementations. But the developer still have to review and decide what to apply. The level 3 is conditional automation, which is like DiffBlue test generation or Transcoder code porting. This level parallels conditional automation in self-driving, where the systems can perform some certain tasks autonomously under some specific conditions, but it still requires the human intervention in others. In software, this including like automating some discrete tasks, but within clear boundaries. So DiffBlue automatically generates unit tests for your code. So a developer may have to provide existing code, and then the DiffBlue will create corresponding test cases, which significantly speeding up the testing process. However, the developer still have to verify the tests and ensure the correctness. And another is Facebook Transcoder or similar tools, which automatically port the code from one programming language to another. So these tools automatically translate the logic from, let's say, Java to Python, but the developer have to review and adjust for the nuanced cases. And the level 4 is high automation, which is like Devin or OpenDevin, which is end-to-end development. This is where we reach high automation, which is similar to a car like Waymo. That is, the car can drive fully in most conditions, but still has limitations in extreme cases or complex environments. So the same in the software development. This could mean that the tools can take an entire processes or solve full development tasks, from writing, testing, and even deploying code. The example is Devin or OpenDevin. They are research-oriented tools that are designed to automate significant portions of the software development cycle. For instance, an end-to-end tool that might take the high-level requirements and generate complex applications and write the corresponding tests and even suggest the deployment options. The developer's role becomes more and more supervisory and only intervening in the edge cases or complex decision-making. The last one is level 5, which is full automation. So this is ultimate vision akin to full autonomous vehicle where there's no human intervention is needed. But in the software development, full automation would mean the ability to define high-level goals or requirements, and this system would autonomously generate, test, and deploy the entire solution with no human input needed beyond the initial specification. Let's say we have a hypothetical example. A developer might specify, I need a mobile app that allows users to log in, access their profiles, and receive notifications based on their geolocation. So this system would autonomously generate all the code for the backend, front end, and user interface, and security, testing, and deployment. So there's no manual coding, refactoring, or debugging by humans would be required. But we have not at this point yet with the current technologies.